we're going to now talk about surface area and volume, but to start off with, I'm going to go this way to look at what we call a prism. Now, a prism is a shape that doesn't taper, doesn't like flare out. It's just consistently the same throughout the whole shape. So, for example, the circle at the front is exactly the same size as the circle at the back, and it's constant all the way through. Same here. This front face is constant all the way back, and this triangular face also. And when that happens, we call it a cross section, because it doesn't matter where we cut it, I'd still always see the same shape at the front in exactly the same size. So the volume of any prism is the area of that cross section, so normally the front face, times by the length of the prism, and we call this the length, the distance it goes back. Or sometimes we can call it the depth. Sometimes it makes a little bit more sense when we call it the depth, but for some reason in the test they call it length, so that's what I'm doing. Now, a cone and a pyramid often confuses people, but a cone is just a third of a cylinder. If you imagine the cylinder going straight up, you find a third of that, you get the volume of a cone. So a cylinder is pi r squared, that would be the cross section, a circle going straight up, times the height of that prism, or the depth, but we just find a third for a cone. Same with a cuboid. If you have a cuboid like this, and you find the volume, so length times width times height, and a third of it, you get your pyramid. So that's how I remember. A pyramid is a third of a cone. Sorry, a pyramid is a third of a cuboid, and a cone is a third of a cylinder. But you are given them, so you don't need to remember them. Now, with a cone, we're also given surface area formula, and it's pi times the radius times the length. And what this length actually stands for is slanted length. So they use L's and lengths all over the place to mean different things, so it does get confusing. But this is the L, it means the slanted length there. And height, obviously, is the perpendicular height, like in everything. The height of this is perpendicular. And a sphere, this is a stranger formula, it's 4/3 pi r cubed, and the surface area is 4 pi r squared. Again, you are given all of these formula, apart from the, oh no, you're even given the pyramid one, so that's fine. Okay, so let's look at some questions. So here we have a prism of a cylinder. So the volume is dead easy. So it's the cross section is a circle. I'll just shade in that one so I don't cross out these. So it's pi times radius squared times by the depth or the height or the length of the prism, which is 20. So pi times 6 squared times 20. Punch it into your calculator. Pi times 6 squared times 20. And I get 2,261.9, and let's pretend these are in centimetres, so that's centimetres cubed. Now the surface area is much harder because this is a cylinder which is curved, but a cylinder is literally a rectangle folded up. So if you get your sheet of paper and you fold it and meet the ends, you make a cylinder. So basically it's a rectangle, and then the two circles plus and plus. That's what we've got to do. So we've got to find out the area of this. So I'll draw it down here. We know this is 20, but we don't know this length here. But if you think about it, if I curl this up, it makes a circle. So this length all the way around here must be this length here. And that is circumference, and that's pi times diameter. In this case, the diameter must be 12. So to find the area of this, it's length times width. So I'm going to do pi times 12 times 20. So the area is 753.98. And I'm just going to keep that on my screen. Now, that's the curved area. Now chuck on the circles as well. So plus brackets. I just do 1, so pi times radius squared. So pi times 6 squared, close my bracket, hit equals. I'm going to do that again, so I'm going to open my bracket, pi times 6 squared, close my bracket, hit equals, and there I have it. So just for the examiner, I'm going to do this. So I'm saying that's the area of the rectangle plus pi times 6 squared plus pi times 6 squared. And all of that equals 980.2 centimeters squared. So the cylinder is actually the hardest one. You'll see that these two are far easier. So let's go to the cone. So the volume of a cone is third of the volume of a cylinder, so that. So times pi times radius, we have the diameter, so the radius is clearly half of that. Sorry, you couldn't see any of that. So what's that? 5.7? Oh, this is actually quite hard to take it back, because when I say this, what I actually mean is height, and I need to know that. Now, I haven't got that, but if I do this, you can see I form a right angle triangle, and I can use Pythagoras. So my triangle I actually have is 5.7 and 12.6. So I'm finding one of the shorter sides. So what I'm going to do here is 12.6 squared take away 5.7 squared using my Pythagoras knowledge. And that is that. And of course I need to square root my answer. So I make this side x to be 11.24. So my height is actually 11.24. So I'm now going to punch this in. So 1 divided by 3 gets my third. I'll just show you what I'm typing in. Times pi equals times 5.7 equals, I just love to hit equals so I don't make any mistakes, times 11.24. And I have rounded that. It's probably better if you can include a few extra numbers, but it shouldn't make too much of a difference. So there we have it. That is the volume of the cone. Now the surface area of a cone, well, this is pi r squared, the bottom surface, but the curved surface area, I'll write it down here, so the curved surface area is pi times radius times the slanted length. So pi times 5.7 times 12.6. So pi times 5.7 times 12.6. So that is 225.63. But of course that's only the curved area. We need to add on this circle at the bottom. So we're going to add on pi times 5.7 squared. So I'm going to do that in my brackets, plus brackets pi times 5.7 squared. Close my bracket, hit equals, and I have a grand total of 327.7 centimeters squared. Last one I'll show you is this. So this is a sphere. So the volume is 4/3 pi r cubed. Helps if I told you a radius, wouldn't it? So let's just make it 5 to make it easy. This one is dead easy. So pi times 5 cubed. Now you're just going to type that into your calculator. I would do 4 divided by 3, press equals, times pi times 5 cubed, and you'll get your answer. I'm conscious this video is taking quite a long time, so I'm going to skip it. And the surface area is 4 pi r squared. Again, 4 times pi times 5 squared. You just punch it in and you'll get your answer. But before I go, I do want to show you this question because it's difficult for one. So, this is a hemisphere, half a sphere, and we're told the curved surface area. So, for a whole sphere, is 4 pi r squared. So the curved area for a hemisphere must be 2 pi r squared. And we're told that is 32 pi. So you should be able to see, if we divide by pi to both sides, there you go, I can get r squared on its own by dividing by 2. And I can get r on its own by square rooting. So that means the radius of this is in fact 4. And we're asked to find its volume, and I do apologise for my awful use of an apostrophe there. I have tried to cross it out. So the volume of a whole sphere is 4/3 pi times radius cubed. So we know the radius is now 4. So I'm going to type that in. So 4 divided by 3 equals times pi times 4 cubed equals 268.08 blah 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 blah. But that is the whole sphere. So to find the volume of a hemisphere, we obviously half it. So divide by 2, and it's 134.04 centimeters cubed to 2 decimal places. Okay guys, that's everything.